Welcome to another thrilling episode of Solid State Cinema with your host, Terry from Dlab Electronics. Today, we're going to be working on another realistic integrated amplifier. This one happens to be the model SA-1000. It's got a problem. Let's see what it is. Here she is, a classic realistic integrated amp with this beautiful brushed aluminum face. The owner sent it to me because the unit was dead. He assumed that the power transformer was fried because it blew the fuse, and he replaced it, and guess what? It blew it again. Well, that's because there's actually a shorted component in the amplifier section, making him believe the transformer is bad. So let me show you what the culprit is. Alright, so here is the inside of the SA-1000. We already talked about the power transformer. Here is your output transistors on a heatsink. They're the original Toshiba 2SD371s. This is your power supply and driver board for the amplifier. So this is your main filter cap. And then these two guys are the coupling caps that go to the speakers. Now the thing that I noticed right off the bat is if you look right down here, this little resistoroid, he's cooked. That should be a 10 ohm resistor, just like the one over here. So right off the bat I'm saying, okay, there's a problem on one channel of this amp, and that's probably what's blowing the fuse. So some quick words of wisdom: if you have an amplifier and it's blowing fuses, don't keep putting in fuses and watching them pop. And you sure never want to overfuse the amp, because then you will fry your power transformer. Because if this guy is seeing a short and the fuse is blowing, it's trying to tell you something, okay? Like that smoked resistor I showed you, don't go in there and just change the resistor and say, well, my amp's fixed, I'm going to turn it back on, because guess what? It's going to burn up the resistor again, and it's going to blow the fuse, because the short is still present. So here's the first thing you want to do. Take your meter, okay? I got an ohm meter right here. And what you're going to do is we're going to go to the heatsink. Now I just want you to touch the collectors of each of these transistors. Okay? So you can see two of them, this one and this one, show continuity to ground. Well, if you look at the schematic, you'll see that it is wired that way, so that's normal. But then this guy should have high resistance, if not open, and so should this one. But guess what? That one is also shorted. So this channel right here has one or possibly two shorted output transistors. That is why the resistor smoked. So the first thing we need to do is clear the short. So I'm going to remove these finals, check them, and I just happen to have a set of old stock replacements that I bought. And these are matched pair Toshiba 2SD371s. So removing the amplifier section in this amplifier is not too bad at all. There's a couple sheet metal screws here and there that you take out, and then the circuit board simply fits in some slots up here. So once these are out, you pull the board back and you flip him up, and you've got access to everything. The thing that you need to do first, though, there's two resistors here that are soldered to these posts. You want to unsolder those and swing those resistors out of the way so that you don't damage them. And of course, make sure before you power it up, you hook them back up. So let's get this board out and inspect the components on it. Alright, before you get all excited and think, man, Terry's going to pop in that new match set of finals, that amp's going to take off running. No, I'm not going to do that, because I need to know what was the cause of those finals shorting to begin with. Was it that maybe somebody in the past hooked up a shorted speaker, or no speaker at all, popped the final? Well, that could be. But with the experience I have working on these older units, I find that normally what happens is the bias shifts on the board due to aging components, especially those old electrolytic caps that originally came with the amp. This thing's like 30, 40 years old, right? So it's got some age on it, and I guarantee you those caps are bad. So not only are we going to put in the new finals, we're also going to change all the electrolytics on that amp board. Oh boy. Once again, my buddy, Dick from the internet. Yeah, so Dlab, why are you working on this junk realistic crap? There's a lot more high-end stereos you can make a few bucks on. You got some kind of a love story for realistic? What's the deal, Dlab? And how come you're using those stock transistors? You should use NTEs or ECGs. You know what, Dick? I really wish that you would just like take off to the great beyond, because I'm really tired of you. Well, it's good to see him boldly go where no troll has gone before. On with the repair! So what you want to do is go through the board and write down every capacitor that's in it, and you're going to see duplicates from one side and the other side of the board, right? Because you have a left and right channel and they both do the same thing, right? So you need to make a list and you need to buy those electrolytics. There's a couple of them that are 63 volt caps, and you want to either meet or exceed that voltage. Don't put in 50 volters because they're going to go off like Jiffy Pop makers, all right? So I always keep a cap kit on hand just for working on these radios. So fortunately, I keep my cap kit stocked for just such an emergency. Sound familiar? Okay, the resistors are unsoldered from those posts. I've got the screws out so I can lift the board up, which gives you pretty good access to the bottom of the circuit board. Those final output transistors, you saw the screws on top, but they're actually soldered in on the bottom. This is your base and emitter leads. So we're going to take some solder wick, take that solder off, of course, take the screws off, lift out the transistors. So you'll probably find it easier to prop the amp up on its face, put something behind it to hold it there. You can get in here with your solder wick and desolder the base and emitter leads on the output transistors. So as soon as I've cleared all this solder away from these, we'll be able to take out the screws and the finals will lift right out. So just in case I'm wrong and we pull the transistors out and they are good, we want to put them back where they belong, right? So we'll call this guy X, okay? And this one's obvious what it is. Get a nut driver, get these nuts off of here. I'll cut back and pull the transistors. I got the hardware off. Remember this red wire now that goes to that collector lead, okay? You're going to need to put that on the new transistors. So there's Mr. X. And there's the other one. Let's get a meter on them. All right, here we go. I got my meter on the diode check position. This is the final that I believe is good, and that's X, which I think is bad, so we're going to just check if I can hold her steady. Here's base emitter. You can see the 0.6 volts, that's good. Base again to collector, that's good. We'll check emitter to collector, and it's open. That's a good transistor check, alright? Now let's check the one that we have suspicions about. Here's my base emitter. Here's base collector. It looks the same, doesn't it? Now let's go emitter collector. Oop, there she is. So Mr. X has a emitter to collector short. Now even though this one checks good, I bought a matched pair of these, so I'm going to change both. Well, here's my new set of the two SD371s that I'm going to install. Even though I was guaranteed they're good, let's just give them a quick check. Good, good, open. Good, good, and open. So they appear to be okay. Let's get them installed. Before you install your new finals, make sure to put a little bit of heat sink compound on the collector case. Yeah, there's still some residual old heat sink compound there from the other transistors, but I wouldn't recommend that you trust that. Get some new goop on it. Got the new finals screwed in, so we'll get these soldered up. And after you solder these, make absolutely sure that you cut off these long posts. You don't have to put it right next to the connection, but you need to cut those off because when you reinstall the amp board, they could touch the bottom of the chassis. It'd be arky sparky time, and guess what? You just blew out your new finals. Our finals are in, so at this time I want to pull out Smokey the resistor. And after I get this changed, we're going to buzz out the other transistoroids and make sure none of those failed when the finals failed. Alright, so at this point what you want to do is take your meter and you're going to verify all these transistors on the board. Luckily they have identified the leads. Okay, so what you want to do is make sure that nothing shorted when the final went. If we got lucky, that 10 ohm resistor saved the other components from damage. So you pretty much get in here. I'm going to block the camera, I'm sure. There's one junction of that driver. And then the collector's kind of hidden down the center. He's good. And then same thing, do the emitter collector. Make sure it didn't short. It didn't. Okay, so that's a good sign. So you want to go through and you want to buzz out every one of the transistors, especially up near the finals, because that's the drivers, and make sure they're not hurt. And if you don't know if it's reading correctly, you've got the other side to compare your readings against, because this side is good. That's the great thing about working on these integrated amps, is you got one side to troubleshoot the other. The other word of advice is try your best to stick with the stock transistors that were in these units to begin with, because the bias was set to those type transistors. If you put in a substitute like an ECG or an NTE, they may not bias and you might not be able to get them to bias. So stick with the originals. So everything buzzes out well. I did not detect any shorts, so I don't think the damage went any further than that final. So now before I power it up, we're going to change out all the caps. So there's the older ones. You can see they're fairly large. Now here are the newer ones. You can see they're like half the size. That's just modern technology. So I'm going to get them swapped out. So there's the smaller caps replaced. Now I'm getting ready to change out the old monster filter cap. And what I'm replacing it with is one of these little snap-in type caps. So you can see the base configuration is different. So what I'm going to do is put the positive in this location, then this blank hole here, the negative will poke out, and I'm going to solder it to the ground, and I'm going to use a wire runner to make that connection. And of course I'll put some adhesive under the cap. So due to the proximity of this positive pad to the lead that I was going to make a runner go into the negative, I decided to do it the opposite way. So this is the negative lead of the cap, and then the runner goes from the positive to this pad. And it's been adhered into the board, so now let's get the board reinstalled and power it up, see if we get smoke. So I was getting ready to check out the amp, and I thought, you know, when this thing came in, it was actually missing the fuse. So I was wondering, maybe somebody did overfuse it? So I got the bright idea to take a look at these rectifier diodes right here. These come right off the power transformer. Watch my meter. Zzz, that guy's gone. Zzz, that guy's gone. So somebody overfused it, shorted out the diodes because there was load out there. It's a good thing I checked it before I applied power. Let's change them out. Or I was able to find some of the original type diodes, and I've replaced those. So we're ready for initial power up. I have a variac. I'd highly recommend, if you work on this stuff, you get a variac, because if you apply full power and there's one item shorted, smoke will come out of this thing, alright? You also need some type of a dummy load. I've got the Dlab test set here, which loads the amp plus has outputs that feed external speakers. And you definitely want to have some speakers on this thing, because if you start hearing this funny hum, you know you got a short and you shut her down. And what I'm going to do initially, we'll bring it up on the variac, and I'm going to take my meter and check voltages on the collectors of those output transistors. And if that all looks good, we'll bring her up to full power. Initial power up time. I've got speakers on A going to the dummy load test set. Got my homebrew Heathkit look-alike variac. Power switch is on. So first thing you want to do is just bring up the voltage and watch that amp meter. If you see it go up at all at this point, you got a problem. Alright? So there's 50 volts and I'm not seeing anything going nuts. Heat sinks are cool as a cucumber. Let's see. I got 7 volts. Of course I turned it all the way down, so let me bring that voltage back up to about 50 volts input. About 15 volts on that guy. 15 volts on that guy. That's good, because that means that the power supplies are working and I don't have any fire. Alright, so now I'm going to bring it back up. 50 volts. Let's take the volume up and see if we hear anything. Yep. Okay. Just means we can pass some noise. Doesn't mean the amp's working yet. So now that I've had it on, just going to feel around in here. Make sure that there's nothing getting warm. And there's not. So let's hook up audio generator and see if we can get a tone out of it. I've got my WaveTech audio generator hooked up to the tuner input. So let's bring our variac up to about 50 to 60 volts like we did before. There it is. Do we have both channels? Yes. So I can get a tone through it. Getting closer. Now I want to get a scope. Take a look at those outputs. See if they're clean. Alright, so we'll take a look at it with a scope. This is an old Heathkit scope I've had down here in the shop and been kind of playing with it. But it's good for this kind of work. So there's the left channel. I'm still only running at around 60 volts. Take it up to about 70. Decent sine wave. Check the right side here. Same deal. So I think we're on the right road. Next step, we're going to bring it up full bore and see if we're getting any heat generation on the heat sinks. But I think that this thing is pretty much fixed. At this point, I'm going to bring her up full voltage. So we're on. There's our 50 to 60 that I've been playing with. Here comes the output. It's about 75 volts. I'm watching my current meter on the variac. Mid-range. Treble. There's our balance. Bass isn't going to do much because of the high frequency we're at. I can bring that down. It's probably not as irritating either. So the bass is working. Take it right up to 100 volts. Heat sink as cool as a cucumber. Let's hook up a CD player. Alright, the moment you've been waiting for, full smoke test. The little SA-1000 is plugged right into the line, no variac to protect it. Got a CD player queued up, ready to go. I have a royalty-free type of CD in it, so you guys can't pop me for copyright. So here we go. Power's up. Select a song that's not too horrible. Here we go. watching on my audio test set, and the wattage is equal on both channels. So that's a good sign. We'll bring up the loudness. I'd say it's fixed. So a successful repair of the realistic SA-1000 integrated amplifier by Solid State Cinema. You see, this lab isn't just for eating crackers and drinking wine anymore. We'll see you again.